All right, so another important thing that we have to work with and navigate in chemistry and in science and, well, tons of other fields is we have to navigate something known as, just a second, scientific notation. One way to think about this, and one of the ways that I like to think about this, is it's efficiency. It's numerical efficiency. And it's like, I guess, kind of honesty in some respects. Basically, the way that it works is you're writing only the significant figures. For instance, if you see the number 92,000,000,000, one thing that's important to recognize with respect to significant figures is you'll notice that there's no decimal position here. And so this digit down here, there's a little bit of uncertainty with that. And so it's really more accurate. And so, sorry, along those lines, since there is no decimal place, none of the zeros in this number are significant. So a much more efficient way to write this number, and a much more realistic way to write this number, is to write the non-zero digits 9 and 2 and then put a decimal between them, and then take into account where the decimal position would be. It would be here: 1 2 3 4 5 6 7 8. So you're going to write 9.2, and then you're going to multiply by 10 to the, and then since we moved our decimal, and since this is a very large number, we're going to have a positive exponent. It's going to be times 10 to the 8th. Okay, so when we're taking a number like this and converting it to scientific notation, one of the ways that I like to think about this is the value of the number greater than 1, or is the number less than 1? And if the answer is it is greater than 1, then you're going to have a positive exponent. If it is less than 1, you're going to have a negative exponent. So if you see a number like this, 3.6 times 10 to the negative third, well, you're going to write that in its kind of complete notation, or its full notation, with all of the possible values without that exponent. And you're going to do so by moving your decimal a total of 3 spaces, and you're going to move it to the left. So you're going to end up with 1 2 3. You're going to end up with 0.0036 as that number converted from scientific notation to what you could kind of refer to as whole notation or complete notation. Okay, so the convention whenever you're writing a number with scientific notation is to have only one digit to the left of the decimal. Once you start out with that, and then you determine if the number is larger than 1 or less than 1, then you can just count up the number of times that you move the decimal, and there you go. There's your exponent. Is it a negative value, or is it a negative exponent, or a positive exponent? That's going to depend based on the number that you're writing. But that pretty much sums up scientific notation. All right, well, have a good one.